Hello viewers, today I'll show you how to develop an NMR spectrum from the raw data, which is essentially the free induction decay file which was obtained from an uh, NMR spectral measurement recorded earlier. Now, the software that I'm going to use for this purpose is the ACD NMR processor, the academic edition. So it is a powerful NMR processor with the various features which makes the development of a spectra a very easy process. Now, in order to begin, let us go to the raw data file that we want to develop in this particular instance. So I'll be developing uh, this file. The sample code is E3IA. So all you have to do is drag and drop the FID file into the NMR spectral processor. So let us select the FID file and we shall drag and drop it to the spectral processor. Now once that is done, we can see certain lines, so we'll have to change it. We'll have to perform a Fourier transform through the software. So we'll go for interactive FT or interactive Fourier transform here. So let us click on the interactive FT button, and rest everything is okay. So let us hit the OK button. So there we have our spectrum. Now, in the first look, the spectrum looks quite okay, but then there are certain changes which can be made. So the first thing that we shall do is go for a baseline correction. Okay, so in order to go for a baseline correction, it is advisable to go through a phase correction first. So you can either correct it manually or automatically. So if we go for automatic correction, we'll get some sort of results. If we go for manual correction, we'll get another sort of result. For manual correction, you'll have to select the mouse phasing and fine tuning, and then you can hold an individual peak and adjust the baseline until clear and symmetric baseline is developed. Anyways, there is another option of getting the baseline correction done. For that, you'll have to click the baseline button here. Click on the auto mode. The auto mode will select the baseline on its own, and then we'll have to click the green correct sign here so that the change is accepted. Okay, so we are done with the baseline correction. Now let us try and identify the peaks. So let us go for peak picking. Now see, you can see in front of your screen. As soon as I click the peak picking button, let me repeat it for you. Peak picking button, then strong solvent and water impurity signals have been detected. This particular message has popped up. So what to do? We will just click OK here to identify which is the peak due to the water and the solvent. Generally, when it comes to solvents like DMSO, a very strong HOD interaction is seen between proton transfer is seen between DMSO and water, which results in a very strong peak, which often dwarfs the other peak that we are more interested in. Okay, so generally it is advisable to remove the solvent peak before proceeding with further development of the spectrum. So let us remove the solvent peak. So For removing the solvent peak, we'll go to process, then remove solvent signal. So while executing this command, any integrals or any labels that have been added to the spectra will be removed. So let us click OK. Then we will drag this red lines to the region which the peak covers and the region which we want to remove. So let us drag it carefully. Okay, done. So once we have selected the solvent peak which we want to remove, we shall have to click on the result button here. So the result is there right in front of our eyes. Now it is advisable after removal of a peak to perform an immediate baseline correction. So let us go to the phase, and we will go for the auto baseline optimization here, so that the baseline is optimized. Okay, so it is optimized pretty well actually. So for further optimization, you can go for direct baseline correction, and once again you can select the auto mode, and then accept the changes. Okay, now we have removed the peak, one of the solvent peak. Let us try and remove the other solvent peak. Process, remove solvent peak. Okay, so we'll follow the exact thing that we did earlier. We'll drag the red lines to the section which we want to remove, and then select the solvent peak, and then simply go for the remove option. So there we go. Okay, so let us go for the baseline optimization again. Done. So baseline correction. Okay, we'll go for the auto mode at first. Okay, now see, there are certain problems here. The problem arises because of improper recognition of the baseline on part of the software. So anyways, it can simply be resolved. So instead of auto, we'll go for the set point modes, and then we shall set points here, so that the deviation from normal baseline can be addressed. So we can manually set the baseline to correct itself. Okay, okay, so that seems fair enough. Now we can move it a bit higher. Okay, that actually looks better. Anyways, so let us click the accept changes button. Okay, so this more or less looks good. So let us see if any other changes can be made. Yes, here we can make certain changes. Okay, I think so that should be fine. So let us accept the changes. Okay, done. So uh, Let us see if there are any other option that we can explore. Okay. Uh, okay. So that's it. Okay. Now that the baseline is corrected, we'll simply go for the peak picking options now. See, there are multiple peaks here, so we can directly actually go for auto level of the peak, or we can go level the peak one by one. So for one by one, we have to click on the peak by peak button and select the peak. So we have a peak at minus 2.95. We have a peak at 0, which must be because of the solvent TMS, and we have a peak at 2.73 here, 2.89 here, 3.92 here, 4.03 here. Okay. For we also have a peak at 10.04 here. For others, let me expand the aromatic region. Okay. So it seems to be a combination of peaks. So anyways, let us try leveling it manually. Something at 7.95, a doublet at 8.00. Okay. So there are a number of peaks here. Also, I can see two peaks here. Now this is quite tricky. So let us expand this particular peak, and then I think so we'll have a better picture. Okay. So in a sense, it's showing that there is only one peak. However, uh, we can adjust the noise factor, because it to me it seems like there are other peaks, shoulder peaks, which the software is not being able to recognize. So we can try hitting the auto button, but before that, let us change the option a bit. Okay. Yeah. So detect shoulder peak option is selected. So let us click OK and go for the auto detection of peak. So you see the these peaks have been highlighted. So this particular peak here is actually a combination of peak instead of a single peak. Anyways, with our peaks fully developed, we have our spectrum. The dark region, it can be retained or it can be deleted, but it depends on your requirement, whether you want to show the dark regions or you want to delete the dark regions. If you want to delete it, simply delete the dark regions. So we can delete it from here also. So let us deselect it. So this will be deselected. Now our NMR spectra is fully developed. So we can export the NMR spectral data into a PDF file.